The number of shots in a complete rectangular pile is 24,395. If there are 34 shots in the breadth of the base, how many are there in its length? So we have already seen that the number of shots in a rectangular pile where the longer side is m, okay, longer side is m and shorter side is n. We know that the number, if you arrange the balls in a rectangular pile, the total number of balls are given by over here n times n plus 1 divided by 6, 3m minus n plus 1. We have already seen how to derive this formula in the earlier video, so I recommend that you watch that video again. I will use the formula directly. We know that the number of balls is given by n times n plus 1 times 3m minus n plus 1, this divided by 6, right? Now we have been given that this number is actually equal to 2, 4, 3, 9, 5, and we have also been given that that n is equal to 34. We have also been given that n is equal to 34, and we simply have to solve this problem now. So this is a simple 1 by 6 times 34 into 35 into 3m minus 34 plus 1 is minus 33 is equal to 24395, and therefore this becomes 1 by 6 into 34 into 35 into 3 times m minus 11 is equal to 24395, and we get m minus 11 is equal to 24395 divided by 17 divided by 35, and this comes out to okay, we can use the calculator here, so this will come out to 41, okay, and therefore m will be equal to 41 plus 11 is 52. So this is solution for problem number 6. Let us look at problem number 7. The number of shots in the top layer of a square pile is 169 and in the lowest layer is 1089. So we know that this arrangement of the pyramid is square, okay. How many shots does the pile contain? So we know that the top layer is 169, which is actually 13 square, right? 13 square is 169, and we know that the bottommost layer is 1089, and this is actually equal to 33 square, okay. So we know that the bottommost layer is 33 square. So imagine a complete pyramid with 33 square, okay. So how many balls will be there in that complete pyramid? It will be simply sigma of n square 1 to 33, right, and this will be given by 33 into 33 plus 1 is 34 into 2 times 33 plus 1 is 67 divided by 6. Okay, I am just using this formula. Sigma of n square is equal to n times n plus 1 times 2n plus 1 by 6, right? So over here we have n is equal to 33. So in the complete pyramid we have these many balls, right? Now imagine the top layer is having 13, a square of side 13, right? So if we lift the pyramid with, if we consider the pyramid with side as 12 squares, right? If we consider the base where there is only 12 squares here, 12 balls here, so we have a pyramid of 12 balls. So we will consider this pyramid. If we subtract this pyramid from the pyramid of 33 balls in the base, we will get the total number of balls that we have to find. So what is the number of balls in a complete pyramid of 12 squares? 12 balls. I'm confusing my language, I'm using wrong words. Okay, so this is going to be 12 times 13 times 25 divided by 6. So if I subtract this from this, I will get the number of balls in a pyramid with 13 balls at the top and 33 balls at the bottom. So that will be equal to 1 by 6 times 33 into 34 into 67 minus 12 times 13 into 25, and if you calculate this will be simply equal to 11,879, right? So this is problem number 7. Okay, let us look at problem number 8 and 9 together, because problem number 8 is very simple. Find the number of shots in a complete rectangular pile of 15 courses having 20 shots in the longer side. So we know that longer side m is equal to 20, but what about n? You will see that n is going to be equal to 15. 15 courses means that there are 15 layers, right? So only if n is equal to 15 in the lowermost layer, by the time it comes to the top, it will become n is equal to 1. So n is equal to 15 at the bottom layer and n is equal to 1 at the topmost layer. So with this knowledge, we know that the number of balls is going to be simply 1 by 6 times n, which is 15, times n plus 1, which is 16, times 3m plus n minus 1. So 3 times 20 minus 15 plus 1. And if you solve this, you will get the total number of balls equal to 1840, right? This is problem number 8. So this was a straight application of formula, so I will not spend too much of time here. Now let us look at problem number 9. Find the number of shots in an incomplete rectangular pile and the number of shots in the sides of its upper course. Find the number of shots in an incomplete rectangular pile, the number of shots in the sides of its upper course being 11 and 18, and the number of shots in the shorter side of its lower course being 30. So now we have been given that it's an incomplete rectangular pile. Okay, so on the top layer you have 11 and 18, okay, and on the bottom you have this side now is 30. Okay, so this was 11 here on the top, and but on the bottommost layer, the lowest course, the shorter side is 30, and this one is what we have to find. What will be the number of balls in the longer side? Now you can see that with each layer, that is just after 11 it will become 12, right? And similarly, if it was 11 on the shorter side, this is 18, so the next layer here will become 19, right? So what is the difference between 11 and 30? The difference between 11 and 30 is 30 minus 11 is actually equal to 19, right? So 18 plus 19 is 37, so this should be 37, right? So now we have to find what is the total number of balls in this arrangement. So let us consider what happens if we consider the complete pyramid. Okay, in that case you can think that the number of balls are going to be 1 by 6 times 30 into 31 into 2 times 30 plus 1 is 30 into 31 into 3 times 37 minus 30 plus 1. So this is the number of balls if we consider the complete pyramid. Okay, now consider what happens if we consider a layer just above it, right? In that it will have 10 balls on the shorter side. So this was complete pyramid of complete rectangular pile of 37 by 30 balls. Okay, consider pile of 17 by 10 balls. Okay, 17 by 10 balls, so that will be having 1 by 6 into 10 into 10 plus 1 is 11 into 3 times 17 is 51 minus 10 plus 1. So this will be the number of balls in the pile of 17 by 10 balls. So if I subtract this from this, I will get the answer for 9. So you can use the calculator for doing this calculation. And you will get this one as 11,940 balls. Okay, all you have to do is subtract this from this. And this is the last problem that we will do in the same video, because this is also a very easy problem. What is the number of shots required to complete a rectangular pile having 15 and 6 shots in the longer and shorter side respectively of its upper course? So we have already been given the upper course. Now we have to find how many balls we need to complete this rectangular pile. Obviously we need a rectangular pile, a complete rectangular pile of 14 balls in the longer side by 5 balls in the shorter side. So we have to just find how many balls are there in the complete rectangular pile with 14 balls in the longer side and 5 balls in the shorter side. So that is equal to 1 by 6 times 5 times 5 plus 1 is 6 times 3 times 14 is 42 minus 5 plus 1, and if you calculate this, this cancels here. 42 minus 4 is 38, and 38 times 5 is actually equal to, so you get 38 times 5, 5 times 8 is 40, and 190. So you need 190 balls, and that's it. So we will complete this video here, and we will look next problems in the next video.